All right, great. Yeah, so I think you've heard a lot about agents and LLMs and such throughout this entire conference. And here I'm towards the end, about to add one more thing in the mix. And this is something I've been developing in my spare time over about the last year, and in parallel to a lot of other packages and tools and things in this space. And so I'll tell you about today. It's has some interesting features. But, when I set out to do this, I was mostly kind of thinking about, how can we enable people to use these agents, these LLMs, as part of their analytical workflow, right? So one way that we conceptualize this as a community is with this diagram from the R for Data Science book, which I actually won a copy of last night, but then gave away, but to somebody who can make a lot better use out of it. But taking this paradigm here, you can see how there are a lot of things where agents can help out with, right? So in terms of how you might generate pipelines, even implement pipelines for data munging, for data querying, for harmonizing data, how you might then generate workflows that perform the sort of iterative exploratory analysis, and then generate reports and summaries, allow people to ask questions about what happened, and then and importantly even then capture that feedback and then use that to reinforce the way that the agent is operating. But these are the types of ways in which I think you could apply these tools, and I've even thought about it like more in sort of the enterprise context. If you're building large data platforms, how these things can also sort of extend every layer of that, and kind of at the interface layer, I find these particularly interesting because I've done a lot of thinking kind of earlier in my career around the design of graphical user interfaces for data visualization and analysis, and how they would complement command line interfaces. And yeah, I see these natural language, these large language models as providing a natural language interface that brings a lot more flexibility than you would find in a graphical user interface. We are very much constraining and trying to keep, maintain a simple interface, towards the flexibility of a command line, but in one which that is much more natural to a human being who's used to communicating a natural language. Now, of course, there are various caveats that people have touched upon in this conference. Even really key though is getting these things enough context so they understand what you mean and do the right thing. All right, but until recently, there weren't too many R tools for constructing agents, and so then I went off and I made this, and its overall goal is to allow R to talk to different agent implementations, providers, and then also to integrate. This thing on the right here is the MCP, the Model Context Protocol. It's a centralized way to provide tools to these agents, and so trying to bring all that together into somebody programming with R. Some distinctive features of the wizrd package. It provides a fluent, functional interface for constructing them. Kind of defines a grammar for that. And just kind of has this model of treating them as R functions, and this package is also very heavily based on S7, so it uses S7 as a means for representing the structure of the data that should go into and then out of the model, and then there's also this mature MCP client that I mentioned that has a lot of nice features. All right, so, just kind of taking a step back and thinking about how we would build one of these agents, it really depends on having the right context, instructions, the tools available for it to do its work, and then it can take whatever you're talking about and then leverage an LLM to interpret the language and to produce language and implement logic with these tools and all the context available to it, and then accept and return either structured or unstructured data. So this is kind of how I had conceptualized the design of the package. So you kind of have a chat context that you're maintaining. It's immutable, so you you're creating a copy of it each time as you kind of build it up. It's just sort of nice and idiomatic in R. And then you have this agent that you're talking to, and kind of a key link to how it communicates to these underlying language models is through this generic called Textify. Well, there are two generics, Textify and Detextify, that communicate back and forth and allow you to do some convenient mapping of R constructs to text. And then so the agent can call tools, which are just implemented as R functions. It's pretty obvious. There's an object framework around text formats. So you're always targeting a text format. This can be either just text, plain text, or JSON, or it has a glue format where you can specify prompt templates. You can also have a retrieval augmented format where you're doing RAG, so it's performing a query against a text store. So there's some rudimentary functionality for chunking text and indexing it into a vector store and then querying that. But kind of one of the cool things too is around the JSON schema mapping to S7, which makes it pretty natural to integrate with our workflows. And of course, all of this is sort of abstracted in the sense of like you can implement this using different things. So far, I've only done the OpenAI implementation, but it'd be relatively trivial to add more. All right, so it kind of defines a grammar for doing this, for defining this in a fairly natural way. So you start out with constructing an agent that talks to some provider, model, and then you configure in different ways, say instruct it to do things. So you're defining the system prompt. You can equip it with tools. You can do a prompt as to specify the input format, for example, like a glue template format. Output as to specify the output format. And then demonstrate to tell it some examples of what it should do, which is really powerful. And then you call like chat if you want to maintain the chat context, or just predict to generate a single output. And I also sort of start thinking about this grammar sort of mapping into how you would just naturally think of as a function. So prompt as is like you define the parameters of the function, instruct is the logic, equip is tools that this thing can call out to, this function can delegate to, and then output as your return value, and then demonstrate kind of gives it an end-to-end example of how this should work, which is also really nice, really useful for the agent. And so there actually is like an as.function agent method where you can just kind of turn all this into an R function. All right, so I'm just going to quickly go through a little vignette here. A little bit bigger. It's probably big enough. All right. So, it allows you to get started pretty quickly. So it uses this thing called llama file from Mozilla, which is it's a big fat binary that has the weights and the executable. It's cross-platform, and so you just download this one file, and then it can run, say, some llama model or whatever, something that runs on top of llama CPP. And so you can just get that, and you can ask it the question like, okay, describe the MT cards data set, and then it'll kind of describe it to you. It has all that built-in knowledge. This is a demonstration of a chat, so you can maintain context, right? So I say chat, and then I can follow that with another chat that refers back to the previous one. How do you know what it means when you ask how do I manipulate it? So that lies on the chat context. So it tells you some stuff about that. And getting a little more complicated, you can, as I said, you can have this glue format, glue template. I mean, I guess glue is really a string interpolation package, but I was kind of using it as a templating engine. And so you can ask it to, say, analyze the relationship between two variables, and then you can just pass those as a list of parameters into chat, and they can tell you how it might want to analyze those. You can instruct it with additional logic, telling it to calculate the correlation, but it doesn't. It's not really good at statistics like that right out of the box. Just using just tokens and this LLM. So you can what we'd want to do really is give it an actual R function to calculate the correlation. So you can do that. You can equip that. And yeah, and now you can do some output constraints as well. So let's say you just want the correlation back as a single number. We just give it the class numeric S7 class, and then it'll just return a numeric vector. You can tell it I want to output it as empty cars. So now it uses the data frame as a sort of template for, as a prototype, as it were, for what columns it needs to have there, and then ask it to filter actually for you. And it's pretty good at that. It can do that pretty reliably. And so you can, for the small, simple data set, so you can put that in there, and it gives you out a data frame now with those exact columns. You can also give it new types of data frames like this, when you're asking it to summarize things, and anyway, so that's all cool. I'll show you. Let me show you another thing here. So I've got now this model context protocol is pretty fun because you can just take external databases, external services, and various tools, various kinds, and then plug them into your agent, plug them into R pretty easily. And so what this is a Python server that is using PyBiomart to talk to a database called Biomart, which is something developed around storing genomic annotations, right? So genes, for example, on the genome, and on all the different identifiers and coordinates and things like that. And so now we can start that up. It's just embedded now in the package. So we just say start MCP. We give it this Python file. This actually uses like reticulate and things behind the scenes to start this up in a clean way. Then you can connect to it. So there are a lot of MCP servers written in Python, so it's something that you'd want to support out of the box. You can also connect to the actual remote server. This actually does some dynamic OAuth stuff that I implemented on top of Hitter 2, which is pretty nice. It probably should be pulled out of the package, but anyway, so what you can do with this thing is pretty cool. So now you can say, okay, have an OpenAI agent. I can equip it with these tools that I got from the Biomart MCP server. Those are written in Python. And then you can kind of tell it, okay, you're an expert in these gene annotations. So you can answer these questions using this Biomart database and return it as a data frame. And then you can just ask a natural language. So question, okay, here's the question, like what are the chromosomal coordinates for T53 and BRCA2? All right, so you can ask a simple question like that, and then you can, by the way, tell it to output as, right? And you just give it the as.data frame result of an empty G range. So that gives you like your prototype data frame, right? That you can then, when you get the output, you can then call this bioconnector function to make the G ranges from the data frame, and you actually get a G ranges object, this bioconnector object, with these gene coordinates. And that's something you can take directly into your workflows, right? Now, if you're going to try to use this using the Biomart package, which is a direct interface to Biomart from R, which is, by the way better than the PyBiomart. So the model is actually having to suffer using this Python interface. It's actually a lot easier to use the R interface, but it's still complicated for a human because you got to know the various column names or attribute names and keys and identifiers, and you have to know all these things, and it takes a while to kind of figure that out every time you go in and do this. And so this is the equivalent Biomart code if you're going to do that directly, right? So it's actually a lot simpler just to ask what are the chromosomal coordinates for these two genes and get back the same object. And you can ask all sorts of things. You can ask like, okay, tell me all the entree gene IDs and gene symbols and map kinase activity. And this is pretty cool because it has, like, map kinase activity is something that I think the LLM just kind of knows about. So it knows which genes are associated with map kinase activity and gets something right there. You can ask it about this particular Go term. Anyway, so you can ask it all these questions that would take quite a bit of time for a person to figure out how to query this database for and do it pretty quickly. And it's cool to watch the thing work too because it takes multiple attempts to get this stuff right. Like it tries different identifiers and it reads the error message and it says, no, that's not the right identifier, it doesn't exist. And it's like, okay, well, map to this identifier. This, and it actually kind of, it's fun to watch it kind of think its way through how to query this thing. It's actually just how maybe a human might, but it does it all for you. Okay, so that is it. So this is just showing how the MCP stuff works, but basically it just provides all these ingredients for your agent. All right, good. So here I just kind of wrap up. I think Wizrd has some broader applications, or there's things that I implemented in it that can be split out as their own package. There are. I'm really interested in using S7 to describe types more generally, not just to LLMs, but to say web services in Plumber or to an ID, just to have a common way to specify R types. And it goes beyond just classes and things. I mean, it goes into like how you would specify like a particular format of a data frame or a scalar or whatever. So anyway, we're thinking about that in the S7 context. And this S7 to JSON schema bindings is something I think that could be really generally useful. Yeah, and then probably the MCP server stuff could also be split out. The JSON RPC layer underneath that, the dynamic OAuth stuff could all be shared. Anyway, this is it. I'm happy to answer any questions.